Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Lear, a global leader in automotive seating and electrical systems.
This is Autoline After Hours with Gary Vasilash, episode 369 for March 17th, 2017. Ford goes further with 3D printing. Watch Autoline After Hours live at Autoline.tv every Thursday at 3 p.m. Eastern Time. That's 12 p.m. Pacific Time. You can subscribe to this podcast for free by searching for Autoline in iTunes, Stitcher, or on YouTube. Okay, thank you for joining us this afternoon or whenever you're watching the show. As you can see, John is not here today. John is in Santa Barbara, California, where he's driving the Honda Clarity, the car that's powered by hydrogen. I had the opportunity to drive that car earlier this week. And for those of you who are writing things on your calendar, March 30th, we will actually have a Honda Clarity in the studio, so you'll be sure to want to watch that. But I'm glad you're watching right now, and want to introduce folks we have in the audience in the studio here with me today. We have from Navigant Research, a leading research firm that knows all kinds of stuff about everything automotive as well as other things. And I'm going to destroy his last name. And Sam and I were talking about this early. It's Sam Abuelsamid.
Close enough.
Close enough.
Yeah.
So,
pleasure to be here as always, Gary.
And Mike Martinez, the last time we had you on the show, you were at the Detroit News. Now you're at Automotive News.
I made the switch.
You made the switch, and you seem to be enjoying yourself.
Having a great time. Thanks for having me.
And so does the Mike and Mike podcast still exist?
The Mic'd Up podcast had to die, but stay tuned. We have some stuff up our sleeves.
That's his colleague Mike Whalen, who also is now with him at Automotive News.
Yep.
But our special guest, Ellen Lee from the Ford Motor Company. She's a technical leader for additive manufacturing there.
That's right.
So welcome.
Thanks for having me.
Okay, so for the people who have heard all the buzz about additive manufacturing and 3D printing, what is it and why is it important?
So additive manufacturing, there's a lot of buzz right now. It seems like something new, but it's actually been around for quite some time. It just refers to a family of processes where you're selectively adding material layer by layer to create a three-dimensional form. So that's opposed to molding something or subtractively manufacturing something.
So machining and taking away the metal.
Right. So instead, adding it only where you need it.
Mm-hmm.
Not exactly, but as much as we can, only where we need it. And the beauty is that you can create a three-dimensional form, pretty much anything that you want from scratch, so it's ideal for prototyping. Mm-hmm. There's been a lot of development recently, and so a lot of people are interested in looking at extending the functional use of these three-dimensional parts beyond just prototyping. Mm-hmm. And that's why it's so exciting today.
So somebody basically creates a CAD model, so they design it in the computer, and it would have all of these holes and shapes and things like that that would be very difficult to otherwise produce, and then you print it, or...
Right. So because of 3D printing allows you to place material where you want it, there are a lot more design freedoms than with conventional molding or forming processes. And so now you can start doing things that are much more complex in shape that might give you different function. And that's kind of the beauty around how you get every last benefit out of a 3D printed part.
Mm-hmm. So why does a car company concern itself with this? I mean, you guys are making, I looked, last year in the US alone, Ford sold 2.6 million vehicles. Okay, you guys make a lot of stuff, and you're really good at making stampings and cutting metal. Yep. So additive, why?
I think there's a lot of potential in additive manufacturing because it really changes how you think about how to make things. And so at this point, we really need to understand where it can help us become more efficient in all of our processes. Mm-hmm. So just like about 30 years ago when the first SLA machines came out, we started using it for prototyping, and it really reduced the cycle times for new designs for vehicles. And so it's incorporated into every single program that we use to help make that process more efficient. So now we're looking at, what other processes that we have at Ford that can be made more efficient through 3D printing technologies.
So what do you guys think about this?
Well, I mean, I can definitely see the benefits of 3D printing or additive manufacturing for doing things like prototyping parts, so you can make initial parts and try things out without having to build the tools, to take the time and the enormous amount of money it takes to build tools for injection molding or castings, things like that. But is this a process that can scale up to doing mass manufacturing, or is it strictly for low volume applications?
That's the big question. So if you're looking at what's available in today's technology, it's not ready for mass production. So when we look at low volume production, we're starting to see possibilities in certain areas for certain types of applications. But as these technologies progress and we get faster and more durable materials, we can see that potentially that would move forward. But it gives, the other thing that we can think about is personalization. So maybe we're interested in making millions of vehicles, but if each one needs to be different or personalized to the consumer, then that may give us an advantage.
We have a question from the audience here. We'll get yours in a second. So this is Mac Murphy via Twitter saying, are you printing parts for the interior, the engine bay? What materials are you using? And this is an interesting, and maybe this goes to your personalization. What about 3D printing aftermarket add-ons to customize your car?
Yeah, those are all areas of interest. I think customization, aftermarket things, there are a lot of customers who want their car to be just for them. So that's certainly something that we're looking at. Right now, what we're printing, it's mainly prototypes. So when we're looking at new designs and putting things into our prototype vehicles to test some aspects of the vehicles, we look at things that go into the interior, also exterior components, underhood components.
You guys, I did see you guys did an intake manifold that you'd printed and were actually running air through to see if that would work.
Yeah, the intake manifolds that's an interesting case study because they're very complex to mold. So the tools that are needed to make those take a very long time to make. And whenever we have a new engine design, the air intake manifold has to be redesigned. And so we've extended it so much that those intake manifolds can go onto engines, onto dyno testing, and can even be tested on our prototype vehicles.
So these are things that you printed and you're actually putting on a dyno that historically would be a metal part of, or
those
plastic.
Those intake manifolds are usually injection molded plastic. But yeah, there are some that have survived over 100,000 miles.
Wow.
That have been printed. So that's a really great case because then we can start to reduce the amount that we spend on prototype tooling for proving out all of the airflow and cooling and so forth.
Mike, I interrupted you.
Oh, you're fine. But I was just curious what sort of materials, right? It seems like that's the biggest challenge these days, right? Obviously, a lot of the 3D printing we've seen, some of the examples are plastic-based. But when it comes down to mass producing millions of these things, can they withstand the heat and the cold and what a car would need to go through? So are you looking at stuff beyond plastic, and if so, what? Yeah,
traditionally the 3D printing equipment manufacturers have really been serving prototyping needs. And then as we've moved forward, aerospace and medical have been the big drivers. So some of the materials that are functional have been developed for those industries. So what we're really doing now is to understand how we can develop new materials that can be printed that are automotive grade materials. So plastics and thermoplastics and thermosets, composite materials we're looking at, but we're also very interested in metals, different metal alloys.
So Daniel Gray via Twitter saying, are you printing with biomaterials, bamboo by chance?
There has been a lot out there, especially in the makerspace, for printing with bio-based materials. PLA is one of the most common, easiest plastics to print with, which is bio-derived. And there's a lot of interest in putting natural fibers in there too. So these are things that we're interested in. I don't know if there's necessarily a fit for a production material that we would investigate using one of those natural fiber materials. I think eventually we would go in that direction because, as you may know, Ford has a huge interest in sustainable materials.
Sure. So, now there are a whole bunch of different types of processes: the fused deposition modeling, stereolithography, ink jetting. I mean, is there a preferred process that you guys have in terms of, that you're really concentrating on?
There isn't. That's a great question. Because they're so different, the materials that are available are very different. The resolution or the speed that you can print at are all quite different depending on which technology you're talking about. So I think it really depends on what application we're looking for. So traditionally, SLA has very, very good resolution. It's great for us to do prototypes of new concept vehicles if we need something that looks really nice. But it's not really a robust, durable, tough material that you can get out of it. Whereas some certain applications that require high temperature or structural stability, those we might look at metals for. So you would use one of the metal-based processes. So I think it really depends on which application we need. So we are very interested in all of the different types of 3D printing and trying to expand our program to cover all of those.
So the stereolithography, for those who are not familiar with it, that's where you have the vat of plastic and then you take a laser which is driven by the CAD program that you've processed, and then it goes over and it hardens and then it builds that way, right?
Exactly. So they are photoactive materials that cure on exposure to the light.
And then the metal one is basically you're having metal powders that are then being melted by a laser or some other device to, again, build things up.
Right. So the most common metal is a powder bed process where you're using metal powders.
Okay.
But there are also other systems that are wire-fed and where you direct the energy to melt the material, kind of similar to FDM, but for metals, much higher temperature. Or you can direct a powder where you want the material and melt that with a laser or an E-beam or something.
So you guys are working with Stratasys, a company that makes this equipment to make large parts. So these things have basically been sort of bread box size things you can make, and now you guys are looking to do things the size of spoilers. Could you talk about that?
Yeah, so the things that we're trying to address is how to make it more useful for the manufacturing environment. And so we'd like to be able to scale the things that we print, both in the size as well as the speed or the throughput at which we can make the articles. So one aspect is to go big. And what Stratasys has done is they have a demonstration technology. It's still in the prototype stages. But now they've taken FDM, where it's kind of the hot glue gun method, where you build up typically. They've turned that on its side. And so now we build on the side of a platform, and we're able to build continuously out in that horizontal Z direction so that we can get an infinite length part.
And so the aerospace industry obviously is interested in this as well, and you guys, and so it seems like the end users and the equipment vendors may help create technologies that'll make this more useful for Ford or
the strategy we're taking is really to partner or collaborate with technology providers early on enough so that we can provide input about what we need from those processes and from the materials to suit our needs.
Okay. All right, so we're going to take a quick break here, and we've got a number of questions here, and I know you guys have more questions, and so I'll let you ask them. So we're going to hear from our friends at Bridgestone. Okay, we're back with Ellen Lee. Okay, this question from Kurt 1736, I think is probably like the $1 million question that you probably get asked by some executives at your company. How many years away are you from printing a 3D car?
You're right, that's the $1 million question. So it's been done. Kind of gimmicky cars like Local Motors has, Oak Ridge has printed some kind of flashy looking cars, a tank and a Shelby Mustang. So I think we're already there. But I think the big question is, would you want to 3D print a car? So that's the big question we really have to think about. Technically, you would most likely be able to print most components of a vehicle, but does it make sense to do that? And which components would make the most sense 3D printing, and which would you maintain conventional mass production processes?
Okay, 2 questions from Armand. How many years have you been experimenting with 3D printing, and has Ford's racing program approached you?
So Ford has been using 3D printing for 26 or 27 years.
Wow.
Most for prototyping. Last year, our prototype facilities produced about 250,000 prototype parts for all of our vehicles. And a big part of that is for race vehicles. So our racing program utilizes that quite a bit because most of their applications, or a lot of their applications, are just 1 or 2. Right, so it's perfect for those applications.
So these are real parts that are being used on the cars, or are these just prototype parts that are being used?
Once in a while, for a racing program, if there is a part that needs to be installed for one race that there's no mold or tool for, then it would be something that goes onto a vehicle. It wouldn't be something really structural, but some of those parts do go onto cars that complete races. But we also do a lot of prototyping for both racing program and our regular vehicle programs.
Dealerships?
No, not yet.
Okay.
But that's a great application. So that's something that we are looking at.
Okay. See, Armand, so dealerships. Guys?
Going back to the question of materials, I think probably most people, when they think of 3D printing or additive manufacturing, they think of the MakerBot style thing, feeding a filament, and most of the things that I think would have been done with additive manufacturing are homogeneous materials. One material for the whole part. What about doing composites? You mentioned composites briefly earlier. I mean, is it possible to do things like carbon fiber composites or Kevlar composites with additive manufacturing?
Yes, it is. There are some commercial systems out there that do use composite materials through SLS. A lot of these cases, you're using a very fine powder or kind of low aspect ratio fibers along with the powders. But there are new technologies that are coming out today that will allow true composite properties as well. So those are things that we're very, very interested because the properties and being able to lightweight some of these applications.
So would that involve having multiple types of materials that you would inject and fuse together, or would that be something where you might lay up the fibers and then do the 3D printing of the resin onto the fiber, or maybe both? I mean,
there are all sorts of technologies that that encompass both of those. So sometimes there's a dry mix of the fibers and the plastic material that are fused together. Sometimes there is a filament that has fibers compounded in so that you can print it with the fiber in there. There are some systems that will lay continuous fibers in through one nozzle and then inject the material through the plastic material through another. Okay. So a lot of those possibilities exist today or are being developed today.
So we have another audience question that's sort of along these lines from Chuck Grenshi. Can you insert a rigid skeleton into the printer and then print around it so you're binding the final product to the supporting core?
I think that it could be possible. I don't think it's possible to, well, it may be possible in some startup companies today. There are some companies that are looking at using 5-axis robots to be able to deposit material. So in that case, if you have a skeleton already, you could be able to follow contours and reinforce in certain areas.
And so for the 5-axis robot, it's basically like a person's arm, more or less,
Yeah,
that
so
it can move up and under and over, around, and so on. Okay.
So you could print Westworld robots then?
Sure, why not? That would be a great application.
I still think one of the most interesting applications here is on the dealer side, right? And I know Ford's been doing a lot to expand the amount of parts that they offer and to, in some cases, simplify them so there's not as much complication there. I mean, theoretically, could we see a future where an individual dealer could have their own printer and you call them up and just say, hey, my need some new brake pads, and they don't have that particular style, so they just 3D print a brake pad or other parts like that?
Yeah, never say never. I think that's a great application. one of the things that we would have to work through is to make sure that those things that are printed would perform exactly the same as the factory installed parts, and that the dealer has the capability of producing them at the same quality level. But that's certainly something that would be really interesting concept in the future.
Well, isn't the military sort of interested in being able to have the ability to actually make parts in the field when something breaks, and that they could use 3D printing for that?
Yeah. In fact, there was an example that I just heard about recently where NASA is interested in that as well in space.
Right.
So if their astronauts, something breaks down, they have a printer there. They, NASA sends a file and they print it, and then they're ready to repair whatever it is that's broken. So the same concept for the military as well.
Yeah, we wouldn't have seen Apollo 13, the movie, because they would have just printed this thing, right? It would have been.
That's right.
All right.
It would have been a boring movie.
So yeah, just watch the printer. Okay, Kelly from Chicago. Now this is like you were talking about spring training. This is like a fungo. Isn't that when you throw the ball real easy and you hit it? How far? Kelly from Chicago asks, how far ahead of other manufacturers is Ford with 3D printing?
Oh, we're way ahead.
See?
We're like,
bam.
That's really hard to say.
You guys have been doing it for a long time, though. I mean, it's.
Yeah, we have. So one of the SLA printers we had was serial number 3.
Wow.
So we got involved in the area very early on. But it's kind of hard to say. We're not, telling all our secrets with the other automotive OEMs. So
right.
We kind of have to guess what they're doing and.
But do you sort of see that other companies, other auto companies are also pursuing this sort of thing that you guys are doing in trying different technologies and trying different parts and so on?
I believe they are. In fact, for our American colleagues, GM and FCA, we do have a lot of pre-competitive research in different areas going on, and this is one area where we do talk quite a bit.
What sort of advancements have been made in terms of time to print things over the years?
Oh, the speed of printing? It depends on which technology, but there are some technologies that are much 10 to 100 times faster than where we were even 5 years ago, I would say.
So what accounts for that speed? I mean, how have you been able to, that's pretty significant change.
So, for example, the infinite build technology from Stratasys, they've moved from having a filament-fed system to a pellet, a very small pellet, using an extruder. So the extruder allows them to get a much faster throughput of the material. And they say that they're working on new screw technologies and different pellet sizes to go even faster than they can right now. So, for example, for the thermoplastic or fused filament or extrusion methods, that's one thing that can help speed.
And for those of you who are not familiar with a filament, it's basically like fishing line, plastic fishing line that she's talking about, and it comes in different diameters. And then the extruder thing is there's a canister of powder, and then this stuff is pushed out basically and melted, and that sort of like toothpaste in a way, no?
Yeah, a little bit. Or if you have, toothpaste is already kind of
a liquid. But I mean, when it comes out, it's sort of
comes out as a continuous kind of melt.
Yeah, mushy stuff.
That's
the technical term, mushy stuff.
I like to compare it to a hot glue gun. So you start out with a solid piece of plastic. It's hot. You push it through, and it comes out molten. So you can form where it goes, and then it freezes relatively quickly in air.
So with this infinite build printer from Stratasys, if you wanted to build, for example, a prototype spoiler, full width spoiler for a Mustang, how long would a part like that take to produce?
That size part, depending on the exact geometry and how it would have to be supported, would probably take about a day or two, which sounds like a long time compared to, if you injection molded it or something like that. But it is quite a large part. Today, with today's technology, making it with FDM, or you'd have to do it in pieces and then glue it together. So we significantly reduced the amount of time by at least half, but probably around a fifth of the time.
Okay, so this will be sort of our wrap-up question. This is from A.M. Guerrero from the Philippines. We're seen everywhere.
Wow.
What is the future of 3D printed parts?
Oh, that's a tough one. I think we will, in the future, I don't know how long into the future, we will see 3D printed parts, anywhere we go. In your vehicle, there's already some in the aerospace industry, prosthetics, in the medical industry. Dental uses a lot of 3D printed applications. So I think anywhere you go, you will see 3D printed parts. Construction, furniture.
So knees, crowns, hearing aids, chairs.
Clothes, food.
Food.
Yeah.
Really?
They're 3D printing candy and chocolates and things like that.
Yeah?
You
You guys are very clever.
Well, I'm not doing that.
Well, but your colleagues in the broader sense of the term.
Yes.
So, but some technologies develop and others go away. So do you see us basically on the edge of 3D printing, additive manufacturing becoming something that is not considered alternative but is mainstream within auto?
I see it will have a big place in automotive, not necessarily for producing all of the parts that go on the vehicle. That will really be determined by how we cover these gaps in the speed and the size and the materials and so forth. It seems like it's going in that direction, so I would be hopeful that there would be some parts, but it may not be a major use. But I have no doubt that there will be a huge place for additive manufacturing. There already is, but an even larger place in the automotive manufacturing industry.
Good. So, Ellen Lee, thank you very much for coming. So,
thank you.
Heading up Ford's research into additive manufacturing, and it's amazing stuff. So, we're going to take a quick break, and we'll be back with more.
This is 37 Seconds in the Autoline Garage. Italian power, Italian style, Italian performance, all wrapped around a very non-Italian price. All hail the new Giulia from Alfa Romeo and FCA. Built at its plant halfway between Rome and Naples, Alfa produces 3 versions of this performance sedan, starting with its $72,000 halo car, the Quadrifoglio, powered by a 505 horsepower V6 twin turbo. And though the TI and base Giulia might not come with the same power or carbon fiber extras, with the same looks and at nearly half the cost, you might mistake the car's iconic logo as your own lucky 4-leaf clover. This has been 37 Seconds in the Autoline Garage.
So look for more of those 37 seconds, autoline.tv. Check it out. So I mentioned at the top of the show that on March 30th, we're going to have a Honda Clarity in the studio. Now, I want you to get your calendars out, write these things down. March 23rd, which is next Thursday, we're going to have a Jeep Compass in the studio, and Mark Allen, who's the head of Jeep Design, will be here. He's a great guy. I think you'll really want to see that show. Again, March 30th, the Honda Clarity. April 6th, the Hyundai Ioniq, which is a very interesting project or vehicle in that they have a EV, a regular hybrid, and a plug-in hybrid all on the same platform. Clarity's taking sort of that notion as well of having multiple vehicles on the same platform. And on April 13th, New York Auto Show, and there'll be something special happening there, so we're not going to talk about that. So mark those things down and be sure to watch. Of course, we wanted you to watch all the time, so just every Thursday, just come 3 p.m. So, all right, this is a part of the show where I come up with a number, and this is sort of morphed into where I ask you guys what this number might be, okay? So Carmen, please bring up the number. 8.1 miles per hour, okay? Now the average walking speed is 3.1 miles per hour. So what could that number represent?
I think I know. I think that's the speed of the local motors Ollie that it travels around at.
I was going to say the speed of that new Q-Line light rail system in downtown Detroit. That thing's going to be slow.
Wow. Well, that is the average speed in Manhattan.
Wow. I wouldn't have thought it was that high.
And it's down 12% from 2010. You know, and it's sort of interesting that, you know, it sort of strikes me that we're having all of these, you were mentioning the Q line, so this is a new light rail system that they have in Detroit. You mentioned the Ollie, which is the local motors, not wholly...
An autonomous shuttle.
It's a little autonomous shuttle sort of thing, and yet, we see a place like New York where the speed is going down, not going up. And it doesn't sort of seem counterintuitive that, we're advancing technology, yet we're not going any faster?
Well, I mean, we keep adding more and more vehicles to the road, more and more people trying to get around. And, I think in 2014, for the first time, more than half the world's population lived in cities and urban centers. And I think by 2050, that's projected to be somewhere around between 2/3 and 3/4 of the population. That'll be around 9.5 billion people living in cities. So, to me, it seems perfectly logical that it's going to get slower and slower unless we do something about it.
I think that's why you're seeing companies like Ford working on what they call mobility solutions, right? Beyond just cars and trucks, bicycles, shuttles, so some non-traditional ways of getting around, right? The first last mile solution will get you close, but maybe you walk, maybe you take a bike that last little bit to speed things up a bit.
Yeah, it almost seems inconceivable that you think about companies that are thinking along those lines of doing things like that are not automobiles. And you're talking about how cities are going to become more congested, and that sort of leads me to think about, so where the Trump administration is talking about restarting the review of CAFE for 2025 and reducing the funding for the EPA. What is your sense of what that's going to end up?
I think that as far as the CAFE numbers, I think they did announce yesterday that they're going to reopen the review. It was originally scheduled to be the midterm review, a 2-year process, ending in spring of next year, in spring of 2018. And so basically they've gone back to that original schedule after it was cut short in January, just before the inauguration. I think ultimately it's probably not going to have any significant impact on car makers' product planning and product development strategies, because they still have to develop more efficient vehicles for global markets, and all the big automakers are global players now. So they still have to develop vehicles to meet those global standards, as well as places like California. I think what it'll do is it'll probably impact their marketing strategies. If there is a rollback of the fuel economy, the national fuel economy standards, you'll see them putting less emphasis on selling high efficiency vehicles in places like Texas and the Southeast, where gas is relatively cheap and there's not much demand for those vehicles. They can sell, trucks and utilities with higher profit margins, and then use that to offset sales of the electrified vehicles that they have to sell in California and the other states that follow the California ZEV mandates.
So how's that different from what they're doing now? I mean, they're selling every truck they possibly can in Texas, and
well, if they don't have to hit the same national average, then they won't have to put incentives to sell as many of those higher efficiency vehicles on a nationwide basis. They can focus those just on the regions where they're needed, and they can sell more of the more powerful vehicles that are also higher profit margin in those regions, and not have to incentivize the sales of those vehicles.
What's your take on it?
I think what's interesting is to see what's going to come ahead with kind of the new cast of characters that are in charge of making some of these decisions, especially Scott Pruitt over at the EPA. Now all of a sudden you have somebody who is a climate change skeptic, who is going against some of the facts that the industry has kind of universally acknowledged. The automakers have never really had a problem with the science behind what the Obama administration was doing. I think their whole gripe was the cost, right? And so when you see kind of those factors at play, you would think that maybe you'll start to see some rollbacks, because I think Pruitt said in his statement yesterday that we have to make sure these are affordable for consumers. So he's with them on the cost. And there's also that other kind of caveat about him not really believing that carbon dioxide is hurting the environment that much. So you think there's going to be some relief there. You get the $2 a gallon gas you got everybody going into cars or into trucks and SUVs. So it's definitely a different world than when they first signed these agreements. What was it, 2011? So it's there's plenty of market changes and changes at the top who they're dealing with as well.
Yeah, I mean, the fundamental issue with fuel economy standards has always been, they only address the supply side of the problem. Saying to manufacturers, okay, you have to build vehicles that hit these fuel economy targets, but politicians, for obvious reasons, have never been willing to do anything or to do much on the demand side to stimulate the demand for those vehicles. Especially when gas was cheap here. In 2010, 2011, when gas was $3.50, $4 a gallon, it wasn't a problem to go ahead and do this. Everybody agreed to it because they figured gas was going to stay more expensive and go even higher. But when gas prices went down, when the oil prices crashed, it made it more difficult because you didn't have the demand from the consumer side to support the sales of these higher efficiency vehicles.
But you put your finger on something earlier, I think, that when you mentioned that these are global companies and they're developing global platforms for global markets, and the European Union and and China have regulations that are going to be coming into play within the next few years here, such that it's almost analogous to what's going on if we go for the 2025 CAFE regulation. So does this mean that automakers are going to be developing vehicles for the U.S. market that will be less fuel efficient than other markets?
I think what we'll see is that they just won't apply some of the technologies to the vehicles that they sell here. Like, for example, 48-volt electrical systems and mild hybrids. You'll probably see fewer applications of that on the models they sell here as opposed to Europe. In Europe, you've got higher fuel prices already, so there is a consumer demand for that technology. So you'll see them selling, you'll see Ford selling Mondeos in Europe, perhaps with 48-volt mild hybrid systems in addition to high voltage hybrids. But you won't see those on the Fusions they sell here as one example.
Which will basically raise their engineering costs.
Not necessarily. I mean, it's just a matter of they're developing those technologies anyway, so it's just a matter of leaving some of the pieces off here. So yeah, I mean, there may be some, you've got some more variability, from market to market, but you have that anyway. I mean, you've got different engine variations that you're selling in different markets. So it's just some of those more expensive technologies will get left off the most of the vehicles that are sold here.
One thing I did think was interesting and maybe a little telling, less than 24 hours before the president came to Detroit, Ford tweeted out kind of reaffirming its commitment to electrification here in the U.S., $4.5 billion by the end of the decade, 13 electrified vehicles. They just put out a little tweet saying, hey, here's what we're going to be doing no matter what happens. So we'll see if they stick with that.
So do you sort of think that, we're going to end up with sort of like two strata of vehicles? One that would be the advanced technology vehicle, whether it be the Ford electric bike vehicle or the aforementioned Honda Clarity hydrogen fuel cell vehicle, and then the other sort of bread and butter cars and trucks that will not have the advanced technology. We had a few months ago, we had the Valeo had developed an electric supercharger, and it was on a Continental. We had it was on a MKZ that we had in the studio here. So that's 48-volt technology. That would not be here. That might be in Europe.
Exactly.
And so the technology in the United States then, in terms of automobiles on this lower strata, would just be
so what you would get is
advanced.
You get an MKZ that's sold in this market, or a Fusion sold in this market with a 2-liter EcoBoost, and in Europe you might have the Mondeo with a 1.5-liter engine and a 48-volt mild hybrid system attached to it.
Well, I thought it was interesting that I was trying to look for some very non-political aspects of what additional, if we roll back some of these regulations. We all think this may, not we all think, but some people think that rolling back regulations is a good idea. And I was looking that there was a study that was done in Southern California of lung function growth for children as a result of pollution from automobiles, and it was they discovered looking at 4th, 7th, and 10th graders. Lung function growth was approximately 10% slower among children living in communities with high NO2 levels and other traffic-related pollutants. So I don't think we ever think about, kids being affected by this. And a new study has just come out, and I don't know why this is, but they've discovered that older women who live in places with fine particulate matter exceeding the U.S. Environmental Protection Agency standards are 81% more at risk for global cognitive decline and 92% more likely to develop dementia.
Well, that's the debate, right? We can talk all day about cost and what consumers are buying or not, but at the end of the day, it comes down to health, health of individuals and potentially the health of the planet.
And the other thing to keep in mind too is that just because we have an administration today that's looking at rolling back some of the standards doesn't mean that 4 years from now or 8 years from now we won't have a different administration that's going to go the other way. So I don't think manufacturers want to slow down on their development of the technologies. It's just more a matter of adjusting the timing of when they deploy it. So they want to be ready to go. It's an expensive. It's expensive to develop cars. It's expensive to tool up for production, and we've got long lead times and long production cycles. So they want to be ready with all this stuff anyway, regardless of who's in office at any given point in time.
Okay. Okay, final word on that. We're going to hear from our friends at Lear. We're going to come back and talk about things that don't have to do with pollution. So,
Lear Connexus offers a parental controls application with geofencing that sends notifications regarding driving behavior and location, including curfew alerts, acceleration alerts, and speed alerts. All delivered to a smartphone application that includes vehicle location, driver notifications, and a report card of driving history, including notifications when predefined geographic boundaries are crossed. For more information, visit Lear.com.
okay, and we're back. Okay, we're going to ask some questions of you guys from the audience. Mike Ma says, I had been reading how Magna developed a composite subframe for a prototype Ford vehicle platform. How soon will Ford integrate this type of technology into its production vehicles?
I don't know that answer. Sam, I'm curious if you have any insight.
I think for a composite subframe, we'll probably start seeing something like that, around the 2020, early 2020s timeframe. Perhaps even as soon as this next generation electric vehicle that they've promised that they're going to build in Flat Rock. So maybe 2019, they start seeing parts like that.
I'd be a little surprised if they come out with an electric vehicle with a composite subframe. Very expensive, very expensive.
But they do want to keep the weight down on electric vehicles to offset the weight of the battery pack. So that's one possibility. More likely, you'd see it perhaps on high performance vehicles instead, using it something like that.
Like the Ford GT.
Hey, they do. I mean, you look at the additive manufacturing. They do tend to test a lot of these things out on the racetrack. So,
yeah, I mean, the current GT is the first production vehicle to use Corning Gorilla Glass windshield. So, there are a lot of advanced materials in that vehicle.
Okay. So, sort of a two-thing thing here. So, PSA buys Opel from General Motors, right? And the deal was $2.3 billion. And so I'm sort of curious whether you guys think that this is going to have implications for this market, for coming to America, okay? And we have a question from Roll Tide who wants to know what presence does GM have left in Europe? Corvettes, Camaros, Cadillacs.
very small number.
Are they still going to be sold in Europe?
I believe the plan is now.
That's what I've heard, yeah.
Okay.
I think we're talking less than 1,000 a year.
Total? For everything?
Or for Cadillac, at least.
So, so is PSA, so I understand that PSA has a, and this is a purely car sharing thing where they have some company that they're combined with a French insurance company whereby basically at airports, you leave your car there and somebody can rent it. And they're going to start doing that April 1st in San Francisco and Los Angeles. So do you guys think that this is like they're putting their toe in the water to come back here?
That's certainly a possibility. That's the main thing I've heard as far as a PSA reentry back into the North American market is through some sort of mobility service like that. Inversely, for GM, what they could be looking at in Europe, they have that tiny presence through Cadillac and Chevrolet in Europe. With getting rid of Opel and Vauxhall, one thing they could be potentially looking at doing in Europe is perhaps launching on-demand or autonomous mobility services in the next few years using autonomous bolts. And by doing that, it would be easier for them to launch something like that in Europe, where they don't have to deal with things like dealer networks, which they have here, and it would allow them to selectively get into certain markets, at least in certain cities, where there are increasingly moves towards restrictions on internal combustion engine vehicles operating in those places.
So this would be a variant on Lyft or Maven?
Yeah, building on what they're doing here with Lyft and Maven, and incorporating autonomous bolts as their platform of choice in those markets.
I'd be curious to see. I know one thing that I think it's a little underreported or not talked about enough, in my opinion, is just the deal itself between GM and PSA. You mentioned they sold the brands, but in reality, GM is essentially paying them to take the brands off their hands. It was a $2.3 billion deal, I think.
Right.
But when you dive down into it, GM's paying $3.18 billion, I believe, in terms of pension costs. And then you have some stock options and a bunch of other bullet points where, GM wanted to get out of this market. They're losing money, and they're paying a premium to leave Europe. So I'm not sure how soon they re-enter, in what capacity that may be. But they gave up a lot.
I thought it was interesting. So there's a quote from Dan Amon, who is the president of General Motors, and he told analysts about this deal. He said, quote, "The mass market opportunity in Europe is no longer compelling." Okay. Then I saw a study from JATO Dynamics, which looks at numbers, and it says the European car industry boomed in 2016 with new car registrations for the year totaling 15.14 million units, a 6.5% increase when compared to 2015. So what's not compelling about that?
And you look at a company like Ford.
It's not compelling for GM.
Yeah.
Not necessarily compelling as a whole. But even that, that 6.5% increase, the European market's been lagging for a number of years. And,
right.
So they're starting to make a little bit of a recovery. But
15.4 million is not something to sneeze at.
No, it's not. But compared to China, for example, there were 24 million last year and continuing to grow. And the forecast for the European market is continued. We're looking at continued fairly slow growth. It's probably going to stay, below 16. Probably not much more than about 16 million at the most over the next.
But
decade.
you know what cars they're all buying? They're all buying crossovers and SUVs, the high margin things. So it's just like I mean. It's just surprising to me that GM is losing $1 billion a year in Europe, and other companies seem to be doing okay. And you were mentioning Ford is they did really well last year.
They had record profits, and I think Ford proves the fact that there's opportunity in Europe as long as you have the right mix of vehicles, right? They're kind of focusing on their Vignale brands and kind of the higher end trims, some of their.
So this would be like you were mentioning earlier, like a Fusion. So a Fusion is a Mondeo in Europe, okay, and then they have something on top of that. So explain it to us. Vignale, what is
Vignale? So essentially, they don't sell Lincoln, so they need some sort of luxury variant. So they have the Vignale brand that is kind of, almost like a fancy trim. Here in the U.S.
Yeah, it's a trim level above titanium. I mean, they originally launched the titanium trim levels on their European models back around 2009 or so, before bringing them over here to the North American market. And then when they launched the new Mondeo in 14, I think, they added the Vignale trim level above titanium. And now here in North America, they've started adding the platinum trim levels to Fusion and other models, which are a step above titanium and pretty similar to the Vignale trims in Europe. So, very close to what Lincoln offers here and in China.
And then, I mean, obviously, you look at their turnaround plan, and in addition to the products, there's a lot of hard decisions about closing 3 plants, laying thousands of workers off. There were riots, rallies outside the plants. There was a lot of pushback for what Ford did. So they made some tough decisions. I think they took a look at it early on, maybe a little ahead of schedule, and were able to kind of reap the rewards these past couple of years.
So while we're talking about Europe and or other markets and Ford, A.M. Guerrero, whom we heard from earlier, says Ford has aluminum-intensive full-size pickups and SUVs, but production for both is limited to the United States. Will Ford ever manufacture aluminum-intensive vehicles in other regions?
I would imagine they probably will.
You look at something like an F-150 or a Super Duty, and the amount that goes into retooling the plant, and the complexity of those particular vehicles, and they're the crown jewels of the company. And if they can do it here with those vehicles, it makes a case for doing it anywhere with anything, if it makes sense for them.
Yeah, I mean, certainly, going to aluminum on the trucks, help them get a boost in their fuel economy and the capability on those vehicles in this market. And because, again, those are such high margin vehicles, the extra cost of going to aluminum and with the high volumes and high margins, it made business sense here. I think we probably will see more use of aluminum in other high volume Ford platforms, and as well as from other manufacturers in other parts of the world in the next 5 to 10 years. Especially in order to meet the fuel economy and emissions targets they've got in those countries.
We'll go back to cast iron here. We won't need to worry about that. All right, so there was another big deal that happened. Intel acquired the Israeli company Mobileye, which basically is a company that makes vision systems and software for autonomous vehicles. They paid $15.3 billion, which I find to be ironic that that you could buy a whole car company for 2.3. I mean, it's just like or a whole brand. I mean, but anyway, so I'm wondering, Intel. I mean, clearly the powerhouse of chips that all of us who are operating with Windows computers, practically all of us, because AMD has some action, has Intel inside. Is this going to really accelerate autonomous driving capabilities? Sam?
Intel has been struggling in the last 5 or 6 years, really the last 10 years. You're right, they do dominate the desktop and laptop market, but the desktop and laptop markets have been shrinking over the last half dozen years as everybody has moved to mobile, to smartphones and tablets. And Intel has no presence in that market at all. So they've been looking to get into other markets. So they've been looking to get back into the automotive space. They've been pitching some automotive grade processors based on their server chips, for autonomous applications. And they've got a couple of partnerships that were announced last year that include Mobileye. So they've already been working with.
So they're working with BMW,
and with Delphi.
Right.
So they've got partnerships with those companies along with Mobileye. And Mobileye, they design chips and software for, as you said, the vision systems, and their chips and software are specifically designed or optimized for artificial intelligence applications, so they can pull in their future generation chips, pulling in all these other sensors as well as the cameras, so the LiDAR, the radar, the ultrasonics, fusing those together in a way that's needed for automated vehicles. And then Intel's chips are doing the general purpose processors for controlling the actuators, the steering, the brakes, the acceleration of the vehicles, and the combination of those two. And it's a similar kind of architecture to what NVIDIA is doing. There was also an announcement yesterday from Bosch and NVIDIA to commercialize NVIDIA's technology. Same kind of thing. They've got a.
Well, we heard from ZF earlier at CES was talking about that they're working with them.
GPUs for the sensors, and then regular processors for the actuation. So Intel clearly sees this as a way to get into the automotive market, which in terms of volumes is a lot smaller than mobile devices.
Right.
But certainly in terms of revenues, these are more expensive parts than what you use in phones and tablets, and so they're hoping to get a bigger piece of that pie.
I think this validation of Sergio's whole consolidation theory in the auto space. You're seeing it in the supplier space, in the autonomous car space too, right? That a lot of these different companies have pieces to the puzzle. We're starting to see more and more partnerships and tie-ups to try to speed the integration of these vehicles quicker.
But I mean, does the fact that we have this, agreed Intel is not in phones and they're not in tablets, but there's still a significant number of chips that these guys are producing in software. And so I just wonder whether this, they're taking what is arguably, the dominant vision-based system in getting it, whether this isn't really going to put momentum behind this whole drive toward autonomy.
They're certainly hoping to. And there's another thing to consider as well. Something else that Mobileye announced last year, they're what they call road experience management, which is, they're using, it's another layer of software that they're building into their future systems that takes the images that the camera is capturing and looking for specific objects, looking for static objects in those images, and then getting the location of those objects, transmitting that data back up to the cloud, and then using that and distributing that back to the vehicle fleet again as part of the high-definition map system that's going to be needed for automated vehicles. And so they're going to be collecting a lot of data. I think BMW announced that they're working with Mobileye and HERE. VW is also using the REM.
So
system.
here is the mapping.
Yeah, here's the
BMW, Mercedes,
right.
Volkswagen.
Right, and so this is building another layer on top of the street maps of objects that are in the world,
right.
As well as the real-time updates, so that those objects, when you have those static objects like overpasses and signs and buildings that aren't moving, and the locations of those can be used to triangulate the position of the vehicle at times when you can't get a good GPS signal, for example. And so that data has a lot of potential value, and I think that's probably part of why Intel paid such a high price for Mobileye, because they see the value in that data that they're collecting.
Okay, so Mike, you mentioned Sergio, and you've got a story in Automotive News that was talking about Sergio yesterday in regard to the possible tie-up with Volkswagen. Tell us about that story and what he had to say yesterday. I thought it was rather interesting.
It's like watching a season of The Bachelor. So, as everybody probably knows, Sergio suggested a couple weeks ago in Geneva that
it was just last week. I mean,
Yeah.
it was
that Volkswagen should merge with FCA, and now that PSA has become or will become the number 2 automaker in terms of volume by acquiring Opel and Vauxhall. He kind of tried to retreat from that statement yesterday after the president came to town, saying, listen, I was just saying that if you were playing a game of chess, this is what you would do. If you were Volkswagen, you would merge with us because we're the logical partner here. I don't want to. I have zero interest. But at the same time, he said a couple seconds later, if Matthias Mueller calls me, I'll answer the phone. He knows where I live. So he suggested it a week ago. Now he's saying he has zero interest, but he'll still take offers. So
what do you make of that? Okay, don't be a reporter here. Be an analyst. I read that and I thought that basically what he was saying, because Mueller basically said he hadn't talked to Marchione. Okay, that he had, and so now Marchione's saying, oh, but I'll take the call. Like, I'm surprised there wasn't like a little Chiron thing that had his phone number under.
Exactly. It's almost like he's playing hard to get in a way. I don't know that now he put it out there, but now he's saying, no, I didn't really want it. So maybe trying to drive up the price. I don't know. It's fascinating to watch.
What do you think, Sam?
When I saw your story today about that, Sergio Marchionne has, for the last, 2-3 years, been trying to swing some kind of deal to merge with somebody. I mean, he was pushed really hard for a GM merger, and GM obviously wanted none of that. They didn't want any piece of FCA, and then shifting gears to VW in recent weeks. I don't know. It seemed bizarre. It almost seemed like President Trump said something to him yesterday, saying it's probably not a good idea for you guys to merge with VW. I don't know. I'm mystified about what this one is, other than maybe, as you say, playing hard to get and maybe trying to drive up the price a little bit.
You think there's a little bit of desperation in the air on his part because he did get turned down by GM. He did, essentially kind of get turned down a little bit by VW. So he's holding on. He's still trying. Mm-hmm. We'll see what the next move is. Mm-hmm. I'm not sure what that could be.
Yeah, I mean, maybe VW kind of put out some feelers with a lowball offer, when they started looking at it. Because I guess apparently VW's been starting to do some due diligence on FCA, and maybe they hinted at a lowball offer, and maybe that's why Sergio's backtracking a little bit. Mm-hmm. I don't know.
So, okay, put your crystal ball 5 years from now, will VW own FCA?
I think.
Don't think that hard.
I think FCA will be part of another company. It may not be VW, but I think they will be part of another company.
I'd say, yeah, it makes a lot of sense.
Another company or VW?
Let's go VW.
You're going to go VW?
VW FCA.
Wow, that's a lot of letters there.
And they've already got 12 brands. What's another half dozen, right?
All right, so with that, I think we'll wrap it up. Mark Martinez, I almost said Detroit News.
Auto News.
Auto News. And Sam Abuelsamid. It was better that time?
Absolutely.
Okay. Navigant Research.
Yep.
And so, guys, it's been great. And I told you all that these were the smartest guys that we could have here. They are. And so, okay, next week we're going to have the Compass. Jeep Compass, brand new. It's really, really nice car. Have it in the studio. Mark Allen, who is the head of Jeep design and the aforementioned FCA. I mean, clearly a crown jewel of that company is Jeep. What those guys are doing is just still great.
That's where most of the profits are.
And they do a fantastic job. So, want to thank you all for watching. And again, 3 p.m. next week, Thursday. Be here. Thank you.
Autoline After Hours is brought to you by Bridgestone Tires, your journey, our passion, and by Lear, a global leader in automotive seating and electrical systems.
Visit our website, Autoline.tv, where you can watch us live Thursday afternoons, get your daily news fix with Autoline Daily, and in-depth analysis and interviews with Autoline This Week. There's all that and much more at Autoline.tv.